Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. And you can find even more answers by subscribing to Automation World at subscribeaw.com. I'm David Greenfield, the editor-in-chief at Automation World, and the question we'll be answering in this episode is, what are guide wheels and how are they used in automated linear motion systems? And joining me to answer this question is Brian Burke with Bishop Wisecarver, a supplier of linear and rotary guide technologies and their associated components. So thanks for joining me today, Brian.
Yeah, thank you for the great introduction. I'm happy to be here.
Well, Brian, let's start with the basics. Tell us a bit about guide wheel technology and how it's used in automated systems.
Yeah, I always like to start with a little terminology. We use some words and they might be confused. So in guide wheel, what we're really talking about, it's a ball bearing that has a special shaped outer race. There's different kinds of bearings, a single row ball bearing, a double row ball bearing, and even a tapered roller bearing for really high load capacity applications. We talk about the track. Track is a track or rail, and we're referring to the linear guideways that the bearings roll on. There's a variety of matching shapes and sizes that are meant to pair with the guide wheel. When we add a drive mechanism, we call the assembly an actuator. Our actuators have either belts, chains, lead screws, or ball screw drive types that can be driven with a motor to make an automated system. These products are typically like a building block of an automated system. You can think of them as a Lego kit of parts that get assembled onto machinery to provide motion. So these guide wheels and these linear tracks get bolted to machine frames to provide precise heavy load capacity motion.
So, based on your explanation there, Brian, and looking at the Bishop Wisecarver website, there's several different types of guide wheels available. Can you kind of describe the differences among them?
Yeah, of course. Our most popular type is a V guide wheel, which features a W-shaped outer race. These can run on either the inner V or on the outer V. On the inner V, it runs on a matching V track, and on the outer V, it runs inside a V track channel. This V geometry gives it a constrained motion in multiple degrees of freedom, so it provides smooth linear motion in one direction while being captured in the roll and the pitch direction. Other designs include the crown roller wheels, which feature a slight curve on the outer race. These are typically used on flat tracks where the running surface is flat, and because of the curve on the guide wheel, it can have misalignment. So where they're used opposite of a V track. So you use them in a pair like in a heavy load drawer where one side is the V and it gives it precision, and the other side is a crown roller that allows for some misalignment in the mounting structure. Some people do mount V to V systems, but the installation needs to be very accurate or else it may bind. So these crown rollers prevent binding and make it for easier assembly. The last style is a flat roller. Instead of a slight curve, it actually has a flat surface, and these also roll on flat tracks. And so these are for heavy load capacity that they can move. If it's a flat roller on a flat track, it can actually move in 1 degree of freedom, not angular, but actually kind of in and out as it would slip on that flat track. So as you can see, there's different styles of guide wheels. And to summarize, and overall, the V wheel is the most popular.
So, I guess one of the neat things about guide wheels is it's something that's very easy to understand, even with all the different types and variations as you were describing there. It is, if you've ever put in a new cabinet or sliding drawer, I guess you've encountered some basic, type of guide wheel. So it's easy to understand what they are, but can we get a bit more specific about how they're used in automated systems, and more specifically about their use in linear motion applications? Can you explain that a little bit more?
Oh yeah, of course. But first, I agree with what you're saying. When our products are used by people that commonly use wrenches and hand tools, they love it.
Mhm.
It's
Yeah.
very
Yeah.
simple.
Yeah.
There's hex features. You can use wrenches to adjust and install and tighten it down. and people get a real comfortable feeling with it very quickly, anyone that's hands-on and mechanically inclined. And so, as you can imagine, there's a lot of different places and applications for these types of products. In general, most machines for automation are designed around welded tubular steel frames. A machine builder will design and fabricate this overall structure for all the functions of a machine, and then they design in products that they don't make and that they need to source. Examples might include like the motors, the drives, maybe lights and sensors, and in our case, these linear guide wheels and the linear tracks. These products get assembled onto this machine frame and they provide motion for the moving elements of a machine. There's many possible applications, but one example that I like to talk about is automated packaging machinery. Equipment such as case erectors and case packers. These are machines that start with flat cardboard piled on one side, and the machine will pull the cardboard from a stack, open the box, fold the flaps. Sometimes they'll tape or glue the seams together. Then bundles of products get inserted, and finally the flaps get folded and sometimes taped at the end. A machine like this can process a very large volume of products really quickly and operate in an automatic fashion. When you break down all these functions and each one of the motions in this machine, there's many moving elements that need to be precisely guided so that a repeatable result can occur. Otherwise, you'll get a lot of garbage out real fast. Imagine
Yeah.
if this machine's malfunctioning or not guiding properly, maybe the folded tabs aren't pushed in properly.
So, why are guide wheels considered important for linear motion applications? I know you just described how they work in it, but versus other motion enabling devices that that could be used for this. Why are guide wheels so important for that?
Yeah, there's several key benefits to guide wheel technology, and more specifically, these V guide wheels. They provide very smooth, low friction rolling motion that's efficient to guide very heavy loads. These guide wheels are quiet compared to recirculating ball carriages that you would find in a profile rail. Our wheels generate less sound because the balls inside the bearing are separated internally by ball retainers. This prevents ball to ball contact and the associated sounds that get generated. In a profile rail, the unconstrained balls will hit each other. They bang around and bounce through the ball
Hmm.
return tube as they recirculate, generating much more noise. They can also be used in very long length applications. You can join the tracks end to end, and the wheels can roll over small gaps in these track joints. So you can have a motion system that's 20, 40, even 80 feet long, and these guide wheels can continue to roll. The V guide wheel has a self-cleaning wiping action that sweeps away debris and works in very dirty environments. There's some videos on our YouTube channel that explain it, but in general, because of the V shape, it's as it rolls on a V track, it generates a sweeping action that tends to eject debris, and that's very unique to the design of this guide wheel. They also provide very long lasting and low maintenance. They're internally lubricated with grease that doesn't need to be serviced, and occasionally they need to be cleaned and new oil applied to the track surface. So they're actually very consumer friendly when they're in a machine. They'll last a long time. And speaking about life estimation, one of the things that's unique about our products is that we can estimate the usable service life of the guide wheel bearings. They have known load capacities and statistical travel distances. Then we can use our equations to estimate the expected travel life of a guide wheel. Users and machine builders can schedule replacement to prevent unexpected machine downtime. And so that's something that makes our products rather unique in the market.
Interesting. All right, thanks for explaining that, Brian. So I know in just a moment ago you mentioned a packaging industry application. Can you provide some insight into some other, dominant types of industry applications using linear motion technology with guide wheels?
Yeah, sure. As you mentioned, packaging machinery that, I talked about before, that's a great place for linear guides and V-guide technology. Anywhere there's cardboard or corrugate tends to generate dust and other particles. This type of machinery is found usually after food processing or consumer goods production. It'd be considered end-of-line packaging applications. But there are many applications in food processing like high-volume baking, chicken and meat processing, and other food-related operations. So not just at the end of the line packaging, but also in the processing of that food. Also, along those lines, we're starting to see more mechanization in agriculture with automated harvesters and field related applications that have potential to save labor. There's things
Hmm.
like tractors that will automatically pick strawberries and also, other types of harvesting equipment. There's many different applications in harsh and dirty environments, often where there's material processing such as cutting or welding, places where the materials that they're processing generate particles or debris. This is really where the guide wheel technology can shine and be the best mechanical solution because of that self-cleaning wiping action. These are places where linear guides rapidly fail. Of course, guide wheels can be used in more clean environments, like on various types of lab automation, to provide motion to samples or other processing movements. Some medical applications might include patient tables or physical therapy equipment. And finally, there's this general purpose material handling applications where there's the need to guide or move a heavy or awkward shaped items, perhaps in an assembly or to assist workers.
That was really interesting about all of it, particularly the part about the self-cleaning capabilities of that to be used in dirtier environments or agricultural environments. So, as critical to smooth motion as guide wheels are, as we've been discussing, how does a company like Bishop Wisecarver, for example, differentiate itself in a market where there's so much competition for such a widely produced type of component?
Yeah, that's a great question. We've built our reputation upon very high quality products that operate in very harsh conditions where other competing products tend to fail. We're easy to do business with and we collaborate with people on their projects. Our expert staff provides excellent service and we'll readily share our expertise with you. We have a team of application engineers that are experienced in solving tough challenges. With our sales network and staff, we're always willing to go the extra mile. We're a privately owned US based company located near San Francisco in California, and we can support critical projects and applications where other vendors can't. And so these are some of the factors that separate us from alternatives in the marketplace.
So one last question, Brian. I know your target audience is largely machine builders, end users, of course, as well, but probably predominantly OEMs. So how do you recommend engineers at OEMs, approach the determination of the right guide wheel type for their application, considering the variety of guide wheel types that are available?
Yeah, that's also a good question. We have a lot of product literature and information available on our website, and this literature provides enough technical information for an experienced design engineer to select and size a guide wheel for their application and without any assistance. So some people will do that. They'll actually select and decide and order the products without any assistance. However, I always recommend working with our application engineering team to discuss any critical factors to ensure project success. We have an application data sheet where really important application parameters are recorded and communicated. From there, our engineers provide the free evaluation, product recommendations, and offer custom design solutions. This ensures that any project will meet its objectives. That these are available from our online chat. You can talk with our engineers online and at bwc.com, and you can also reach them by phone by calling the phone numbers on the website. So with that, you can see we like to work and collaborate with people on to ensure success. In our product database, we have thousands of products that might be suitable, and so we can make a recommendation on a specific product that would work for that application.
Thank you again for joining me for this podcast, Brian. And thanks, of course, to all our listeners. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember, you can find us at automationworld.com and subscribe to our print magazine at subscribeaw.com to stay on top of the latest industrial automation technology insights, trends, and news.